Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for everybody. For this time, we will discuss about the sum modeling, especially for the heck wave tsunami modeling. Okay. For this time, we will try to using some models like the mixture, two mixture normal, two mixture variable, two mixture gamma, and then gamma without mixture, log normal without mixture, and then log normal without mixture for the heck wave tsunami data. Okay, we will open the one journal. I think this nice research article was published in the best journal, I think. Okay, we can check the journal. Okay, from this research article, the title of the research article is the distribution of Runnup hack of the December 26, 2004 tsunami in the Indian Ocean. This research article published in the Geophysical Research Letters, volume 33 for 2006. Okay. In this research article, the hex wave tsunami data will be modeled using the simple distribution function, the namely log normal distribution function. So very simple modeling, but of course, okay, for the some earthquakes like tsunami in the some area, like the tsunami in Aceh, I think it's impossible to only use the simple distribution function log normal to the modeling to produce the probability modeling using the heck wave tsunami. I think that's impossible. We have known the tsunami is the extreme earthquakes. So it means, I believe that there is the complicated probability modeling in the heck wave tsunami data, especially tsunami that happened in the Aceh. So that's why I will try to take the some data, heck wave tsunami in the some area in the Aceh. So I'm success to get the data from the some research for the some sources. Okay, we will try to open our R programming to prove that it is impossible to make the simple modeling only by using the log normal distribution for the hex wave data tsunami in the Aceh province, Indonesia. Okay, we open our R programming. Stop share. Okay, we will share our R programming. Okay, this is our R. And then I have input the heck wave data. Like this one is 4.07 meters in the one's area. And then this is 4.82. And then this is this one 31.91 meters. So if we are try to remember again, when earthquake, that tsunami becomes in the Aceh, we believe that in the one area, the hex wave tsunami about around the 31 meters. Okay, I believe that in the Aceh, there is the hex wave tsunami Aceh around that 31.91 meters. So very high the tsunami. 31 meters. I don't know that. Okay. So for this for our discuss today, we will check the first time the histogram of the data. Okay, we run the data. Okay, we comes to our console and try to take the histogram DT tsunami. Frequency equal to false. Okay. Okay. We have checked the histogram. I think is this not good only using the simple distribution. I mean, it is not enough. We are use the gamma waveful or log normal without mixture, or only one component for the gamma waveful or the log normal. Because it seems in the histogram there is 2F here. There is 2F, not 2F, 2F. There is 2F. Okay, this is the first wave, and then this is the second wave. So it's mean we must try use the two mixture distribution function modeling for the high wave tsunami data in the Aceh. Okay, we will try to produce we try to estimate the parameter for the sum modeling that we use, of course, using the R programming. Okay, like we have done before, we are use the mixed air package. I think it is not important to me again to explain you what is the mixed air, because I have talked about the mixed air in some program in the Rado Institute. You can join with Rado Institute, only come to the Google searching and you type Rado Institute and you click the Rado Institute statistic online. You can find around the X100 video. The all of video is about the activity in the university, like teaching, community service, or makes research. Okay. After we are install the mixed air, we use the program library mixed air. So after that, we call X to the data hack web tsunami or hack web tsunami data. And we are trying to use the mixed fits tools in the mixed air to find the parameter, to estimate parameter. For example, fit 5, it means that waveful 2 component or waveful 2 mixture. And then fit 7 is meant for the gamma 2 mixture. Fit X for the gamma 1 mixture. There is no mixture here. And fit 9 waveful no mixture. And the fit 10 is a log normal with the 2 mixture here. Okay, you run X until fits 11. Okay, the whole program have run. You can check For example, fit 5. In the fix 5, we will take the set for the first mixture variable, and then we can find the scale parameter for the first mixture variable with the weighted 0 point blah 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 blah. And then we have the safe parameter safe for the second mixture, and we have the scale for the second mixture, and we have weighted for the second mixture for variable distribution, of course. And you must be remember, if you make summation, the weighted in the mixture, the first mixture, and the weighted in the second mixture must be equal to 1. Okay, from the fit 5, we have the IC and BIC and the log likelihood. IC is mean that the one method to the identified which one the best modeling. The best modeling is the smallest IC. This is for the fit 5. Okay, we can take the fit 9. The fit 9. Not fit 9. We check the fit X. Okay, we type fit X. And then you can find the set parameter for gamma. There is no mixture here, all the with one component. If we say one component, of course, weight it's only one. Set and it's red and it's IC. Okay. After we have find the parameter for the 6 model here, we are use 6 model. There is a variable 2 mixture, gamma 2 mixture, gamma 1 mixture, or gamma 1 component, variable 1 component, log normal 2 mixture, and log normal 1 component, or no mixture in log normal. We use the 6 model because we have make assumption it is not good only use the simple distribution, the distribution function only use the one component. It is not enough. Okay. After we have found the estimate parameter, of course, we will try to make the plot, density plot. Density plot, it means we will try the fit 5 to have how the fit 5 to capture the histogram. That the issue of the density plot. Okay, we'll try our plot. We run the program. Okay, we come to the graphics. You can check by yourself here. There is 2 for the black line. Black line is mean this model for this graph. This is the mixture variable. There is 2 okay? And then for this one is this for the 2 mixture gamma, and then is only 1. This only 1, and then the 2 mixture log normal. From this fact, I think we are agree that everybody in the home or wherever you are who saw our program will believe that the mixture is really happened in this data. So we conclude that if we use the simple modeling, I mean that the distribution without mixture is very, very best model. We have checked from this graph. Okay, the next we are trying to make the cumulative plot. Cumulative plot, of course, we are use the I. I is mean that 0 until length data. And we use N. N is mean the length data. And F is equal to I minus 0.5 equal to N. We call it F is the for the observation cumulative. or cumulative distribution function for the real data, for the observation. And then we try to take the parameter for the sixth model. As it's W1, it means you take the safe variable in the first mixture only. We are use the programming fit 5. Don't forget this 4 and forget this 1. This is double bracket. Okay. And then if we want to take the weighted variable in the first mixture, we call it PPW1 with the programming fit 5, 1, and 1. And if we want to take the scale variable for the mixture, for the second mixtures, we will use the name SCW2 with the programming fit 5. This is 1, 5. This 1, 2. It means we only take the scale for the variable in the second mixture. For the fit 9, we know the fit 9 only 4. Fit 9 what? Fit 9. Fit 9 only 4 variable, no mixture, only 1 component. So that why in the fit 9 we just only use the safe variable, use the fit 9, then this 4, and then scale variable fit 9 is 5. Okay, and then for fit 7 is the gamma 2 mixture. So that why if we are say SHG1, it means we take the safe from the first mixture in the gamma. And if we talk that the PPG2, it means the weighted for the second mixture in the gamma distribution. We are use the fit 7, this 1, and this 2. So we try to take all the parameter. After the all parameter have we found, we try to use the C fix 5. C fix 5 is mean the cumulative distribution function for the gamma. Because the fix 5 is fix 5 is the variable with 2 components. So it's mean of course in the cumulative must have the mixture too. So don't forget when we are talk mixture, of course we are need the weighted for the variable, first variable, and don't forget use P variable. P variable, it mean the cumulative distribution function per variable in the R program. If we are use D it means density, but P for the cumulative. And use the sort data. You must remember that in the cumulative, you must sort the data from the smallest to the highest. In the R, if you make sorts, when you make sort, it means you are sort the data from the smallest to the highest. Use this parameter SHW1 because is the first mixture variable, and then scale variable in the first mixture. Of course, use the summation, and PPW2 is mean the weighted for the second mixture variable distribution. So of course, use the cumulative variable for the sort data Tsunami, and for the parameter safe variable 2. Don't use 1 again, but use 2. Don't forget that. 2 is mean the set for the second mixture in the for the variable distribution. And the same explanation for the all C fix 7, this for mixture gamma. suffix X only for the gamma wizard mixture. So we must use the P gamma only. There is no weighted because this is one component only. So use the sort and this parameter. Same with the suffix 9. This is one component variable. So we don't use the PP11 or PPW2. We don't use that because we have the only one component here. For that why we only use P variable. Remember that P is the cumulative. And then we use sort the data. And this is the parameter set variable and scale variable. After we produce the cumulative distribution function for the 6th model, we try to create the CDF plot. Okay, we try use the CDF plot. We must run the first one, this one. We are run for the all specific. Okay, run here and then use the plot. Okay, we use the plot. This is one plot. Plot the XX. XX it means the sort data. Sort X. FF it means that cumulative observation, like I said before. FF is mean the easy minus 0.5 per n. And then we use the suffix 5 cumulative gamma. Cumulative variable 2 component. XX is sort data. XX is mean the sequence data. Sequence 0 until 2 powers at 2 multiple maximum data 0.1. Because we are need the too much data for the XX. So that why XX is, okay, you can check here. XX, okay, where is XX? XX, which one XX? Oh, we don't have the XX. Where is XX here? XX, where are you, XX? Sort. XX, where are you, XX? Where is XX? X Tsunami. Okay. If you don't have XX, give XX here. Okay, then we have X. Where is XX? Okay, we put XX here. XX sequence 0 until 2 maximum X sequence 0.1. This XX. Okay. Okay, we run here XX until this one. Okay. Okay, until this one. Okay, we run. We check in the console. Okay, the all can be run. Okay, next to the script, back to our script, we run the cumulative plot. Okay, we can check. We run here. Oh, there is no what happened. Close. Check here. Error. Okay. There is problem here. What the problem? Okay, we try run again. We try to okay, we forget it. Okay, we make mistake. XX is mean the sort X. Okay, XX sort X. Okay, sorry, I forget. Okay, so that's why we run again. Okay, XX sort X. Okay, run again. Okay, and we are trying to make the plot cumulative distribution function plot. Run again. Okay, this one, this is good. This nice program. Okay. Okay, we are success to run the CDF plot or the cumulative distribution function plot. You can see from this graph, like the blue one. The blue one is a cumulative distribution function for the variable one component. Or there is no mixture in the variable. The blue one is cannot capture the black one. The black one is the cumulative data. Cumulative data is representative by the FF. FF is the I minus 0.5 divide N. And the for red one, you can check the red one here. The red one is the gamma mixture. The red one can capture the black one. We can see that the black one is this, the red one can capture the black one. And the yellow one is a variable with mixture. And the green one is the gamma without mixture. That is not good because the green one cannot capture the black one. And the gray one is good for the log normal. Okay. From this graph, we have seen the two mixture better than without mixture. Okay, after that, we are trying to make the QQ plot. QQ plot, it's mean we are trying to make the comparison quantile variable data and quantile variable model. Quantile variable data or quantile variable observation, use the quantile variable for FF. FF, we know that I minus 0.5 divide N. You must remember Q is mean the quantile. We are use the weighted for the first mixture for the variable 2 mixture. And then we must use the parameter. We use SHW1 because this is for the first mixture variable. And then for quantile mixture variable is the SHV2. Don't forget that. And use Q. Q for the quantile in the R programming. Okay. We can plot our program for the quantile plot and you can check what happened. Okay. We run. Okay, you can check. When the plot, it seems the straight line is the best model. You can check here, this variable 2 mixture, it seems is straight line. But for this one, this graph is not like the straight line. So it's one is the variable without mixtures. And then for this one, is have the mixture for the log normal, and for this one mixture 2 gamma, and there's no mixture here, and this one no mixture here. So from three graphs that have we discussed, the normally CDF or density plot, okay, density plot, cumulative plot, and the quantile plot, we can take the conclusion mixture is better than no mixture. This is good discussed for today. So after we have the after we take the conclusion on the modeling, use the mixture is the best one, and we must choose only one from the three mixture that we use are to the best model. So to answer this question, we will try to run the fit 5. We are run the fit 7. We run the fit 10. And when we check what happened, okay, we can check from the IC. Fit 5 is weighable mixture. The IC is 630X. And okay, fit 5. And for the gamma, 636. And for the log normal mixture, 630X. So it means the gamma mixture model with two components is the best one model in if we are mixed comparison with the 6 model that we use in this research, because the IC is the smallest than the 6 model that we have done in this research. Okay, from this research, we have concluded. For this research, we are concluded the gamma 2 mixture is the best model. From the graph, from the 3 kind of the graph, density plot, CDF plot, and quantile plot, we are take the conclusion that 3 model use the 2 mixture is the best one. And then after we are try to produce the IC or a KK information criterion, we can see the mixture 2 gamma have the smallest one from the 2 other mixture model. So for this time, we are take the one nice conclusion. The gamma 2 mixture is the best model for the tsunami heat wave data in the Aceh province. Okay. I think this is enough for this time. I think this is enough for this time. We are so very happy now because we are can take the one nice conclusion. I hope what we are discuss for this today so very you can very good, and you can use the R programming to create the others research article. Okay, Rado Yendra from Rado Institute. See you again. Assalamualaikum warahmatullahi wabarakatuh.